right, so similar triangles. This is how I want you to view this topic. I want you to pretend that there is, well, in not all cases, but just pretend that there's a smaller triangle, the one with the arrow here. That's triangle A, B, C, right? And of course, a triangle has three sides and it must have what? Three angles. And by now, everybody knows that all the angles in a triangle, right, add up to how much? 180 degrees. I want you to pretend that this smaller triangle grows up to become a larger triangle. Now, don't get me wrong, it's not always about a smaller triangle growing up to be a bigger triangle. You can have a triangle and then it shrinks to become smaller. But the point is, there's a before situation and there is an after situation. When the triangle is growing or shrinking, in this case, it's growing, right? I want you to imagine that the angles remain the same. The truth is, if you take a triangle and make it larger, like, and you keep all the sides facing the same directions, like you don't mess with the sides. If you make a triangle grow larger, or even if it shrinks to become smaller, the angles do not change, you know. Like, for example, if this angle was 60 degrees, even if it grew up, the angle will still be what? 60 degrees. Only the lengths of the sides actually change. Now, we're going to have something called corresponding sides. Corresponding sides are just the younger version matched with the older version. Do we, and I color coded for you guys here. You all notice this red line grew up to be this longer red line, and this blue line grew up to be this longer blue line. And of course, the same thing goes with the green. So the two red lines are what we call corresponding sides. The two blue lines are also called corresponding sides. And the same thing goes for the green lines. Now, there's a formula. Once triangles grow up or shrink and the angles remain the same, there's a formula that relates both triangles. And this is the formula. Anytime you take two corresponding sides and divide them, like this one is AC, if you divide it by his corresponding side, which is PQ, you will always get the same answer as if you do the same thing with another pair of corresponding sides. So in other words, if I take CB and divide it by his corresponding side, which is QR, both divisions will give you the same exact value. It's like magic. And if you do the same thing for the green side, if you take AB and you divide it by his corresponding side, which is PR, all of these divisions will give you the same exact value. Now, I usually like to put the before sides on top, right? This one here is the before. This is when it was young, and when it grew up, I usually call it the after triangle, the before and after situation. My after values, I usually like to put them underneath. The truth is, some textbooks will have it the opposite way. All the after values, like the PQ, the QR, and the PR, those could go on top, and the before values could go underneath. You would also get the same answer when you are doing calculations, right? But just be consistent about it. But for this class, before values go on top, after values go underneath. Now, obviously, if a triangle, right, grows up, in this case, it's getting bigger, right? Won't the after triangle have a larger area? Obviously, the second triangle, the after triangle, is larger. It must have what? A larger area. To calculate the new area, like area 2, look, I have it here, look, area 2 here. All you have to do is take the area of the first triangle So this triangle here is the before triangle, and you multiply it. Take any pair of corresponding sides. It doesn't matter which pair. In this case here, I am taking what? The red, which one? I'm taking this one. Oh, I'm taking the green ones here. All you have to do is divide both of them and square. But it's kind of hard to understand, that's all. When you're doing the division here, right? A lot of people don't know whether to put the AB on top or the PR underneath. For the areas formula, it matters which one goes on top. The top value will always be the length of the after side. So that's PR. He's part of the after triangle. And the underneath will always be the before side. So if you want to calculate the area after, right, you take the area of the triangle before, that's a small triangle, and multiply by this equation. Don't forget that there's a huge squared here. Don't worry, I'll show you how to use the formula. Take down everything on the screen, and the only way this is going to stick in your head is if we do question after question after question. Let me know when you are finished, and we will move on. And don't worry if you're a little bit confused. I'm sure at least half the class is slightly confused. All of that will be ironed out in a little while. Go. Let's see our first question. So here we have a triangle, right? When you now look at it, right? It actually doesn't look like what? Two triangles. But if you look closely, you will notice something, right? There's a small triangle here. I'm going to put it in pink, right? That's this guy here. I'll draw him in pink, right? And then if you look carefully, there's a second triangle. It's almost like one triangle is overlapping the other triangle. And I'm going to use a different color here. I'm going to use a kind of blue. You always see this triangle here, right? Which is this here. So it comes like you had a smaller triangle, right? And it grew up to be what? A larger triangles. Now, I just letting you know, for this to be the topic of similar triangles, the angles in both triangles must be exactly the same. Now, I just letting you, just take my word for it today, that the angles are exactly the same. So do me a favor, and you need to take down this question fully. I want you all to draw this diagram and then draw two blank triangles. Make one smaller deliberately and make the other one larger deliberately. And the question is asking us to find the length of X, which is from here all the way to here. Right? Let me know. You don't have to work out the question. Just let me know when you finish drawing. I want to work this one out for you. Now, let's put in some letters here, right? For the smaller triangle, right? Here's obviously A. That's this point here. And it has to be B and what? C. So let me put it in B and C. The examiner said from A to C is 2 centimeters. I just leaving out the centimeters. I don't want to clutter up the diagram. And from B to C is X, which we don't know. For the bigger one, it starts at A also. It goes to E. And over here is D. Over here is 6 centimeters. And over here is 3 centimeters. Or is it? What mistake did I make deliberately? What mistake? And this is a common trick played in the exam. What is the mistake I am making on the screen there? No, and I said I deliberately leaving out the centimeters. I don't want to clog up the diagram, right? Clement, correct. Right, Giovanna, correct. Right? All right. So the trick is, right, is from A to E really 3 centimeters? If A, remember this 3 is only from where? C to what? E. The whole length is what? 5. 2 plus the 3. Look out for that small little trick. It's not even much of a trick. It's just that when you're under stress, you will see a 3 and you'll just put 3 there. I've seen a ton of students do that over the years. All right. So from A to E is 5 centimeters. All right. So I see that the centimeters bugging a lot of people. So I will put in the centimeters. All right. So we're going to put in the centimeters. All right. No problem. So the examiner wants us to find X. Now we are assuming that this what is a similar triangle. So you can think of it like this. The pink side grew up to be this pink side. So AC grew up to become AE. And BC grew up to become what? DE. According to similar triangles theory, right? If you take the length of AC and divide it by its new side, the after situation, which is AE, we're supposed to get the same exact answer as if we take the length of BC and divide it by who he grew up to be, which is DE. And all we have to do now, right, is substituting the values and cross multiply to solve for the letter that the examiner asked us to find. So let's go. AC is how much? The length of AC is 2. I'm not going to put the centimeters in the working. Divided by AE. How much is AE? AE is 5, is equal to how much? How much is BC? BC is where? BC is X. We do not know. And we divided by what? DE, which is 6. Now, everyone in this class should be able to cross multiply. Cross multiply and solve for X. And let me know what you get. Right? Don't forget to send the answers on the chat. Let's see what's happening here. Now, remember, when you cross multiply, I always advise if you're solving for X, cross multiply that diagonal first. Right? So 5 by X is just what? 5X. You put your equal and then multiply the other diagonal. 2 by 6 is 12, right? This 5 is a multiply, a secret multiply. Throw him across, he becomes what? A divide. Now it's up to you if you want to put your answers as decimal or you want to put it as a fraction, but you're going to get 2.4 centimeters, or some people will just what? Put 2 and 2/5 centimeters. Any one is correct in the exam. The examiner is not going to care which version you put. All right? So quick question, right? I'm just saying now, right? Let's say I modify this question. I want to make it a little bit different, right? Let's say that I come and tell you now the length of AB, right, is, let me make up my own thing. Let's say AB was 4 centimeters, right? I want you to find the length of AD. I'll put in a question mark here, right? I'll call it Y. I want the length of Y. I need the length of AD, given that AB was how much? 4 centimeters. Let's see what you guys come up with, right? My advice is, right, you only need 2 sets of values, right? So you can either choose the first set of values that you might want to choose is the ACAE, right? ACAE. So if you take AC, remember AC grew up to be AE. So when we take AC and divide it by AE, we're supposed to get the same answer as AB. Remember, AB is going to grow up to be AD. So take AB, which is 4, and divide it by AD. But we don't know the length of AD. Well, let me put this here first, right? And then I'll substitute in the values. We're going to take AB and divide it by the length of AD. So let's substitute in some values, okay? AC is 2 centimeters and AE is 5. All right. Do we know the length of AB? Yes, I gave you it as 4 centimeters. And I ask you to find what? AD. And I ask you to call it Y. So we're solving for the letter Y. Let's cross multiply. Always cross multiply the one with the letter that you are trying to find first. 2 by Y is 2Y. And 4 by 5 is what? 20. Throw across the multiply, you're going to get a divide. Y is equal to 10 centimeters. Okay? So if I come and tell you now, right? If I come and tell you that the area of the first triangle, ABC, let's just say, I write in the area over here, was 24 centimeters squared, right? Now, the next triangle is going to have a different area. And obviously, it has to be what? Larger than the first triangle. Now, remember we said here was 2 centimeters, right? And here was A, here was E, and here was D, right? And we said the length from A to E was 5. Could you all calculate the area of the larger triangle for me using the formula from the beginning of class, right? And let's see what you get. Let's turn back to your formula. It doesn't matter if you get it wrong. I just want you to try it, right? And send an answer. Even if we can't fully remember the formula and you can't remember who have to go on top and who have to go underneath, we could use a little bit of common sense to reason it out. For example, if which one would give me a larger value? 10 divided by 3 or 3 divided by 10 without using a calculator. They just use your mind. Which one will give you a larger value? 10 over 3, or if the 3 was on top of the 10? Or off the top of your head, which one will give you a larger value? Right, the 10 over the 3, right? For you to get a larger value, the top number have to be bigger and the underneath number has to be what? Smaller, right? That's the only way you're going to get a larger value. So to find the area of the larger triangle, so we want to find the area. So you're pretending in the exam and you're fumbling a little bit and you can't remember, hey, something had to go on top and something had to go underneath. But I remember Sir saying you have to take the area of the first triangle, right? The original triangle, the one you're starting off with, right? He said take that area, right, which is 24, and you have to multiply it by something in brackets squared. So there's a fraction inside here, right? Now, corresponding sides have to go inside those brackets. Now, the question is, the two corresponding sides are the 2 and what? The 5. So I know some of you went through this. You have to put the 2 over the 5 or the 5 over the 2. Which one is the correct one? Well, obviously, if you're trying to get a larger area, because the area of the second triangle is larger, the 5 has to go on top. The larger value has to go on top, and the smaller value has to go underneath. Because if you believe me, if you put the 2 on top and the 5 underneath, that will actually make your answer smaller than it needs to what? Be. The answer will get smaller. So this is what you need to work out on your calculator. 24 multiplied by, well, 5 divided by 2 is 2 point, how much? 5 squared. Type in this on your calculator. Make sure you put your brackets and everything. 24 multiply, open your brackets, put 2.5, close your brackets and square it. Or let me just say you lost your calculator now, because sometimes this will come in the multiple choice, right? And in the multiple choice exam, you're not going to have what? A calculator. So you could use your indices skills here. You have 24. I'm going to use this as an excuse here. This squared, if you have 5 over 2, who does the squared belong to? Let me see how much you guys can remember. Does the squared belong to the 5 or does the squared belong to the 2? Which one does it belong to? Right, it was a trick question. It actually belongs to both numbers. Both numbers. So that means the 5 gets squared. 5 squared is what? 25. And 2 squared is what? 4. Both of these get what? Squared. So look at this. Look how easy this is to work out now. And 4 into 4 is 1. And 4 into 24 is 6. 6 multiplied by 25 is 150 centimeters squared. And if you are typing this straight on your calculator, you would get the same exact thing. 150. Look for your mistakes. Not much people made mistakes, but for those who got it wrong, just let me know. Hey, you saw your mistake. Remember, about 5 or 10 minutes ago, we know from D to E was how much? 6 centimeters. Well, that's written on the screen. What's the value from B to C again? That's the value of X. Well, when we had to calculate it at the beginning of the class today, how much was from B to C? Clement, correct. Wasn't here 2.4 centimeters? Remember, we had calculated that. So let's use these two corresponding sides because these two are corresponding sides. BC did grow up to become DE, and DE is the longer one. And I told you the area of this one was 24 centimeters squared. All right, so to find the new area of the larger triangle, you take the original area, which is 24, and you multiply by something in brackets squared. Now, since we need to get a larger answer, the larger length, the larger corresponding length has to go on top, and the smaller corresponding length has to go underneath. 6 is larger than 2.4. So you just need to type in this straight on your calculator. Type in 24 multiplied by open brackets, press 6 divided by 2.4. Close your brackets and square it. Only after you close the bracket, square it. Type it in straight and tell me if you get back 150 centimeters squared. You're going to get the same answer. You're supposed to, actually. Let me know. All right, so here's our next one. They want us to find the length of X. Well, X centimeters is from X to Y. You have 3 things to draw for me. Draw this diagram and then these 2 blank triangles. Deliberately make one smaller and deliberately make one bigger. This one is almost like the previous one, where one triangle is kind of living inside a larger triangle. Right? For those who want to work this one out, feel free. Send the answers. For those who think they still need a second example before you get a little braver to move on, like to do it on your own, just wait a little bit. All right, so let's put in some letters here. So you have the larger triangle. The larger triangle is U, V, and it goes back all the way to Z. U, V, and Z. And then you have a smaller triangle, X, Y, Z. X, Y, and Z. Now, now let me put in some values here, right? From X to Y is X centimeters, right? So just forgive me, right? I'm not going to put the word, I'm not going to write the centimeters. It kind of clutters the diagram, right? from U to V is 6 centimeters. I'll put in a 6 there. Look at that. That's this 6 there. From Y to Z is another 6. But how much is from V to Z? I hope you all don't fall for the same trick twice. What's the value from V to Z? It's 11, right? Right. 5 plus 6 is 11. Right? Let me just write this 6 a little better here. All right. So let's look at the corresponding sides, right? It should be obvious that they're not even trying to trick you with the orientation here. That 6 grew up to be 11, right? And X grew up to be 6, right? So we had to put on a formula for the examiner here. YZ, right, divided by his corresponding side, which is VZ, is equal to what? XY divided by his corresponding side, UV. Everyone take down that formula. You have to put down the formula first before you work it out. And just a quick question, to answer one question. It doesn't matter if you put VZ or ZV, right? It doesn't matter which letter comes first, right? VZ and ZV is the same exact side in maths. So let's substitute in some values. Let's see what's going to happen here. YZ, where's YZ? YZ is 6 divided by VZ. VZ is 11 is equal to XY. Well, we don't know the length of XY, so we're just going to put X divided by UV, which is 6. Cross multiply. Everyone should at least be able to do the cross multiplying part. We did it for almost a term, right? Cross multiply and solve for X, right? Let's cross multiply. I always like to cross multiply the one, if we're solving for X, I cross multiply that diagonal first. I run out of space, so I'll go over here. 11 by X is 11X. Put your equal, and then the other diagonal, 6 by 6 is 36. The 11 is a secret multiply because a number and a letter touching. Throw it across, you get what? A divide. So let's see what you're going to get here. If you want to put it as a decimal, 36 divided by 11 is 3.27 centimeters. I know some of you are going to round it off to 1 decimal place. I'm not going to fight you on it today. So this is correct or this is correct, right? Or you could put it as what? A mixed fraction, right? So I think you'll get 3 and 3/11 centimeters if you put this as a mixed fraction. So I'm accepting any of these answers as the correct answer today, right? Right. Now we're going to try to eventually trick you here today, right? Just take down what you need to take down, and I'm going to try to trick you in a little while. Let me erase a few things here. I don't want to make this too confounded. Right. All right, so we have plenty values here and whatnot. So I come and tell you now that the area of this triangle, I come and tell you the area of this one is, let's call it 120 centimeters squared. And I want you to find the area of this one now. So work this out. Find the area of the smaller triangle, which is XYZ, and send it to me on the chat. Let's see if you fall for this slight trick. Ask yourself first, the answer you're supposed to get for this triangle, is it supposed to be smaller than 120 or larger than 120? Let's predict what our answer is supposed to look like first. Right, Naomi, correct? Right, Sarah correct, Tiffany correct. Right, it's obviously going to get smaller, right? Because this triangle is smaller, so the area has to be smaller than 120. So if we work it out, right, I'm just watching the answers that are being sent on the chat, right? Some of the answers, some people got answers larger than 120. How could a smaller triangle have a larger area than a larger triangle? Doesn't make sense, right? Right, so that's okay, that's okay. So we want to find this area. So I'm going to write the word area. So to find the area, we take the area that they give us. You always take the area that they give you and you multiply it by something in brackets. It's always a fraction in the brackets, squared. Now, you have to look at two corresponding sides. We know this side corresponds to this side. Which value should go on top? The 11 or the 6? Which one should go on top if we want to get a smaller answer? Right, it has to be the 6, right? To get a smaller answer, the smaller number has to go on top and the larger value has to go underneath. That's the only way you're going to get a smaller answer than 120. So this one is going to give a little trouble because you can't really simplify this without a calculator, right? So it's 120 multiply, open your brackets, 6 divided by 11, right? Type it in just like this on the calculator because the 6 comes first. So it's 6 divided by 11. Close the brackets and press the square and tell me what you get. Now, a lot of people did not submit your answers, but at least do this last part for me, Type it in at least and send the answer, and I'll consider it correct, fully correct, right? So it's like a little bonus, right? I am getting 35.70 centimeters squared, right? I see one or two people rounded off to 36, right? Like if you round this off to the nearest whole number, it's 36. I just let you know, your teacher will not let that pass in the exam. Yeah, I mean, the general rule is you have to at least go to 2. So if you put 35.7, all right, your teacher will raise the eyebrow, but he still might give you a chance. But if you round that off to 36, the teacher gonna minus a mark, right? So you try to go to 2 decimal at least in the exam, and in school too. All right, so let's move on, right, to the next slide. Now, I think you all did a lot of work there, so you probably deserve a little small little break here, right? So we go to the genie. Let's see what our genie, right? All right, so let's see what the genie has to say. Let's follow the instructions. This is the prize we can win. You will never be sick for the rest of your life. That seems like a very, very good prize. So let's follow the instructions. If you had to take one fruit to a deserted island, what would it be? It has to be one word, like one fruit. Like pineapple is one word, apple, pomegranate is one word. In other words, what is your favorite fruit? Sarah, really? Watermelon? Right. I'm not even too sure if peanuts is a fruit, but anyway, if you want to take peanuts, you want to take peanuts, right? I think for me, it'll probably be either mango or strawberry, one of those. So anyway, what is the 4th letter? So your chosen fruit, identify the 4th letter, and if it appears in the jar, you win the prize. Let's see.
Let us see what the jar of truth says.
Anybody 4th letter in their favorite fruit was A, G, or E? If so, you win the prize of never being sick for the rest of your life. Okay. Right. If you didn't win, don't worry. We have other games coming up. All right, so let's move on. Right, so this one is a little bit harder because the two triangles don't actually have the same orientation, right? But let's look, let's use a little bit of common sense here, right? And you all remember something called X angles or vertically opposite angles. This is, I believe, in Form 1, something called vertically opposite, oh, I spell that correct, angles. In vertically opposite angles, it's basically a letter X. And all it basically says is that opposite angles, like these two pink angles, will have the same value. So if he is 30 degrees, the other one is also 30 degrees. And if this blue one is 100 degrees, the one on the other side is also 100 degrees. In other words, vertically opposite angles, angles on either side of the X are always equal. So the two blue are equal and the two what? Pink are also equal, right? Now we have to make sure it's easy to mix up which side corresponds to which side, okay? Decide, okay, if you have this angle here, this angle is 90 degrees, right? And over here has a 90 degrees. Isn't this side also opposite the right angle? So is it fair to say that PR and RT are corresponding angles because both of them are opposite the 90 degrees? Well, what do you all think? Is PR and RT, because they have a similar positioning from the 90 degrees, do you think they are corresponding sides? The answer is yes. Those two are corresponding sides. Okay, so I'm going to color code it for you guys, right? So we got a different color here. So him and him are corresponding sides. Which one do you think corresponds to the 7 centimeters? You have 7 centimeters. Which one corresponds to that on the smaller triangle? Is it the X or is it the 2? Which one does the 7 most likely correspond with? Right, and it's a real easy way to figure it out in case you don't know, right? Remember what I told you about vertically opposite angles? You all see an X here? Look at it, it have an X here. Won't this angle and this angle be the same? Because they are vertically opposite angles, like how these two are vertically opposite. Who is opposite this pink angle? Isn't it the 5? And who is opposite this pink angle? The 2. So that means the 5 and the 2 are corresponding sides. So if these two are corresponding sides, then the 2 remaining sides are also what? Corresponding. So it's like a process of elimination. You figure out which 2 pairs are corresponding sides. It's going to be real easy to figure out which 2 pairs are corresponding sides. And the last remaining pair will also be what? Corresponding sides. So yes, the 7 and the X are corresponding, and the 2 and the 5 are also corresponding. Do you all think you all can find the length of X for me? From R to S, which is X? Send the answer across, because you already know which pairs are corresponding. All right. So let's gotta consider one triangle first and one triangle second, right? So it doesn't matter which one you look at first. He could be the before. I'll put B for before, and he could be what? The after. So this small triangle grew up to be the larger triangle. So I already color coded it. I already color coded it for you guys. Okay. So 2, right? Remember, the pink side grew up to be this pink side. So that's ST. divided by his corresponding side, which is PQ, is equal to RS, which is this orange side. So RS grew up to be QR, right? The length of the smaller triangle went on top, and the corresponding sides of the larger triangle went underneath, right? Let's start substituting in some values here, running out of space. ST. ST is 2 divided by PQ, which is 5, is equal to RS. Where's RS? RS is X. That is what the examiner wants us to find, divided by QR, which is 7. It's just a matter of what? Cross multiplying now. 5 by X is 5X. 2 by 7 is 14. So it's just to solve for X, right? Throw across a multiply, you're going to get a divide. 14 divided by, that's the one, 14 divided by, I'm getting 2.8. I'm not too sure why so many people got 5 and 4.3. Right? I'm getting 2.8. I sure correct that. Look for your mistakes. Look for your mistakes. I color coded it. The 2 pinks are corresponding side, and the 2 orange are also corresponding sides. They didn't give you any values of the blue, and they didn't even want you to find any of the blue lines. So you can just ignore the blue lines. Right? So for those who got it wrong, you think you understood your mistake area. So we just found out that this area over here, sorry, this length here was how much? We now figured out it was 2.8. So from R to S is 2.8 centimeters. Okay. Let's say now that I tell you that the area of this triangle here, so of the larger triangle is 100 centimeters squared. I want you to find the area of the smaller triangle. Let's see you all do this one. I give you the area of the larger one. I want you to find the area of the smaller one now. Let's find this area. So there are 2 pairs of corresponding sides, right? We could either use the pink values. Let me color code it. So we could use the 2 and the 5, right? So let's use that first. This is a pair of corresponding sides. So to find the area of the smaller triangle, now the answer for the area of the smaller triangle has to be less than 100. We take the area that they give us, which is the 100, and we multiply by a fraction in brackets squared. Now, if we're trying to get a smaller value, and we look at this pair of corresponding sides, the smaller value has to go on top, which is the 2, and the larger value has to go underneath. If I type in 100 multiplied by open brackets 2 divided by 5 close brackets squared, right? This one, you can actually get it out without a calculator, but let's see. 100 multiplied by open brackets 2 divided by 5 close brackets squared. Oops, sorry, I didn't open my brackets. 1 second. Open brackets 2 divided by 5 close brackets squared. I'm getting exactly 16 centimeters squared. Let's see if I get the same answer if, right? Remember I said I was going to work it out 2 ways, right? So let's see if I get the same answer using the other one. The 7 and the 2.8 are also corresponding sides. So let's see if I will get the same answer. To find the area, I take the area that they give me, 100, multiply by a bracket squared, and there's a fraction here. Now, these two pair of corresponding sides, the smaller one needs to go on top because we're trying to get a smaller answer, and the 7 goes underneath. Let's type it in and see if we get the same thing. 2.8, this one, you can't do it in your head. You have to use a calculator for this one. 100 multiplied by open brackets, 2.8 divided by 7, close brackets, squared. I'm getting exactly 16 centimeters squared. Just don't take my word for it. You physically type it in on your calculator and see it for yourself. When you do it for yourself, it'll stick better in your head, right? The examiner is not going to care which pair of corresponding values you use. You could use the pink one or the orange one. Anyone. It's really up to you. All right. So this one here is a little bit harder. It's going to be everyone take the time and draw this diagram. It's a little clustered, but this 3 centimeters is from E to B, right? E to B. And this 5 centimeters is from B to C. Right? Yeah, but let me neaten up this diagram for you because it's gonna cause some confusion. It's 3 and 5, right? So here's 3 centimeters. I'll write the 5 here. 5. So that way we have no confusion. Right, draw it and let me know when you're ready to start. So the easiest way to figure out which sides correspond, whenever the orientations of the two triangles are not exact, right? Look for the X. Look, isn't there an X here? So that means this angle and this angle have to be the same. The opposite angles in an X have to be the same. So you can just give it a name now. You can probably call him beta, and he will also be beta. So if you have alpha, beta, and this one also has an alpha and a beta, then the missing angle, you can just call it anything. Put any symbol there. You can probably put theta. It doesn't really matter what you call it. Right? So I hope everyone understands that. Try to name all the angles. So alpha and alpha were given to you by the examiner. The two X angles must be equal. So you could call them the same name. And the remaining angles, you give it any name or any symbol, right? You can put a dot if you want. It doesn't really matter. Now, look at this. Who is opposite beta? The 4. And who is opposite the beta here? X. So these two sides are opposite the same angle. So those two have to be what? Corresponding sides. They have to be. So let me color code it. This side and this side are opposite the same angle. So they are corresponding sides. What about this? This 3, who is opposite the theta? Who is opposite the theta? 3. And who is opposite the theta here? The 5. So that means EB and BC are corresponding sides. Okay? Who's opposite alpha? This side. And who's opposite alpha here? BD. But they don't want you to find those things. And of course, they have no interest. It's not interested. It's not, we don't need to know it for the question. So, but which one you want to call the first one? This one going to be the first triangle, and the next one going to be the second triangle, the before and the after. So we want to find X. So AB divided by his corresponding side, which is DC, is equal to EB, and his corresponding side on the other triangle is BC, right? Remember, if you had it the other way, like the underneath values was on top, and the top values was underneath, it would still be correct. You're going to end up with the same answer. So let's substitute in some values here. So far, the most popular answer is 5, how much? 5.2. And some people, one or two people saying 6 point something. Let's substitute in some values. AB, where's AB? I hope I have this correct. And do I have this correct? Anybody see a mistake? I have a mistake on the screen. Tell me what the mistake is. Right, Latoya, correct. Isn't this pink line AE? Doesn't he correspond to DC? It's AE. I have AB by mistake. It's supposed to be AE. Right? It's supposed to be AE. Right. Now I have it correct. AE is 4. Look, I have it here. The corresponding side is X. That's what the examiner wants us to find. EB is how much? EB. EB is 3. And BC is 5. Yeah, just a cross multiply now and we're good to go. 3 by X is 3X. 4 by 5 is 20. Throw across Mr. Multiply, you get what? A divide. 20 divided by 3. I'm getting 6.666666. Or 6 and what? 2/3. Or you want to put 6.67. Anything like that will do. Right? Right? So for the 1 or 2 people who got it wrong, not much people got it wrong. Carissa, you saw a mistake? Just let me know. I think y'all deserve a small break here. Coming close to the end of class, guys. Don't worry, don't worry. Let's pay attention to the rules here. You will be able to communicate with the dead. Well, that will be pretty useful if you become a detective. You'll solve a lot of cases. Let's see who wins this prize. Think about a famous person in history you would like to talk to. So obviously somebody who died, somebody who's famous, right? So if for me, example, it would be probably Einstein, Albert Einstein, right? So who would you like to meet in history who is no longer alive? Like who is your, I don't know, hero from history class or from the History Channel? Let me know, guys. All right, somebody said Muhammad Ali. What is the first letter in the person's name? Right? Now, it's not just about, so for me, it was Albert Einstein. So for me, it's the letter A. So what's going to happen? Look for the letter and tell me what color the letter is. Like for me, A is in the pink. I don't know, that's pink or purple, or whatever color that is. It's in a pinky purple box. Right? So if it's Muhammad Ali, it's M, your color is blue. Let's see if your once your color appears in the jar.
Let us see what the jar of truth says.
Yellow or white? Anybody won this one? Yellow or white? Was your letter yellow or white? If so, you win the prize. I did not win. All right, guys, let's move on. Let's do one more question. One more question. Let me out of here. Right, so get started with this one, right? This is just a past paper question, actually, right? So you all can see that one triangle is clearly living inside the other triangle. And to make things a little bit easier, right? Based on the first question we did today, we know this side and this side correspond for sure. We know these two correspond, right? And the pink ones will correspond and red ones will correspond. So let me just get a few values in. They said px. How much is px? P to x is 4 centimeters. That's from P to x. And x to q, that's this portion, is 6 centimeters also. And QR is 8. They want you to find the length of XY in part 1. So everyone try that for me. Find XY. All right. So the corresponding sides here, right? So let's start. XY corresponds to QR. So XY from the smaller triangle corresponds to QR on the larger triangle. PX on the smaller triangle grows up to become PQ on the larger triangle, the whole length. Let's substitute in the values here. XY is what they want us to find, so I'll just call that X. I'll call from here to here X. That's what they want us to find. QR is 8. It's equal to PX. PX is 4, and I hope you all didn't fall for the trick for PQ. PQ is 10, the 6 plus the 4. Cross multiply. 10 by x is 10x. 4 by 8 is 32. Throw across the multiply, you'll get divide. X is 3.2 centimeters. Alejandro, you saw your mistake? Oh, well, yeah, you corrected there. So XY is 3.2. See if you can do part 2 for me now. Find the area. They want you to find the area of PXY. That's the smaller triangle. And they gave you the area of the larger triangle. Right? So let's hope everyone gets this one correct as it's the last question today. So you want to find the area of the smaller triangle. Keyword, if you read this, it's a smaller triangle. So you take the area that they give you. Well, obviously, this has to be the area of the larger triangle. And you have to put this squared, right? To get a smaller answer, you have to take, well, the two corresponding sides I'm using is these two, right? To me, because it's right in front of me. You're supposed to put a smaller value on top and a larger value underneath. And that is what you type in on your calculator. 50 by open brackets 3.2 divided by 8 close brackets squared. I'm getting 8 exact centimeters squared. Deshaun, check it back. Deshaun, when you was typing it in, you probably forgot the brackets or the squared or something, right? Even if you use the other, right? Even if you use the other one, look at this. The other corresponding sides. 50 multiplied by the small length here is 4, but the larger length is not 6. Remember, I think some people get tied up with this. The larger length of the corresponding side is 10. And if you work this out, you will still get 8. I think some people put in 6 here when they use the second method. Look for your mistake and let me know when you see your mistake. All right? Both answers giving you 8.